This idea of experimental refutation, also called falsification, is essential in science. It's not just a convenient add-on. Be critical of what you hear from some actual scientists, always physicists, on this topic. They are making an error about what science is. But experimental testing, although essential, is not the whole story. It is indispensable, but this is only to say it is necessary, but not sufficient. Far from sufficient. Indeed, many theories never actually need to be tested by an experiment to be refuted scientifically. My listeners will be well aware of David Deutsch's brilliant examples in his book, The Fabric of Reality, where he asks us to consider the theory that eating a kilogram of grass is the cure for the common cold. That is a testable theory. But do we need to do the experiment to refute it? No. And the reason is because we can be critical in another way, another mode of criticism, if you like. Less about the scientific methodology of the situation, and more about the epistemological fundamentals of what is being claimed with the grass-eating theory, or rather, grass-eating prediction. After all, that so-called theory or hypothesis is nothing but a claim of the sort, if you eat the grass, then your cold will be cured. It is a prediction, but contains no explanation. Now, this idea that some claim is predictive, but not explanatory, is both eminently scientific and wonderfully philosophical. We can use both words here deliberately to illustrate that at the boundary, the techniques in science and philosophy really do bridge this permeable wall that separates our rational investigations into the world. Explanations run the entire gamut of our knowledge of the world, but strictly, predictions are the domain of science, properly construed anyway. And even then, good scientific predictions are always subject to what else we might learn in the future that could change what we said was going to happen. For example, a prediction that the world will warm by 3 degrees Celsius in the next 200 years is not an accurate prediction at all if it does not come true. And it might not come true if people do things to alter the course of events such that it never comes to pass that the warming does happen. For example, by sucking carbon dioxide out of the atmosphere using some method yet to be invented, or invented in the next 50 years. Whatever the case, if someone comes to you with a claim that eating grass, for example, will cure your cold, does it need testing? No, because it's explanationless. In my discussion with Naval Ravikant on the Naval podcast, look for that. It's called the Beginning of Infinity podcast. We spoke about actually doing this experiment as David Deutsch does in The Fabric of Reality. If you do the experiment, we would need to specify the quantity of grass. And if we specified it was exactly 1 kilogram of grass, and then we find that eating precisely that amount does not cure the cold, this would not show that 1.1 kilograms of grass would not cure the cold, or that 0.9 kilograms. Or any of an infinite number of variations. Although the hypothesis is falsifiable, it is also infinitely variable, and the experiment cannot possibly refute all variations of it. We can imagine some medical crank saying, well, maybe it's 1.01 kilograms, or 1.001 kilograms, and so on. Experiment really is not the appropriate critical tool here, even though it is one of the critical tools in our critical arsenal. So what else do we have? The appropriate critical tool here is the explanation criteria. What is the explanation criteria? It is the simple distinction between whether or not a claim comes with an explanation or not. It's that simple.